Right, we are looking at question 9, and question 9 is based on what we call Euclidean geometry. In the figure, O is the center of the circle. We can see that O is the center of the circle. A, B, C, D, and E lie on the circle. A, B, C, D, and E lie on the circle such that chord AB, right, we have chord AB and chord DC are equal in length. By good luck, the examiner marked them equal here. Okay, these questions were taken from a past exam paper, and the examiner marked these angles equal for the students. Right, moreover, the angle AEB equals 39 degrees. The angle AEB equals 39 degrees, and this is the angle that equals 39 degrees. Very well. We want to determine the size of angle O1. Want to find the size of this angle here. What is the size of the angle O1? We look at that and look at that very carefully. Who can guess the size of the angle O1? Anyone? Right, anyone? What do you think the size of angle O1 is and why? People are still asleep. Okay, there's a theorem. Theorem like this. If you have an angle that sits here, and then now you have something like this. This angle here equals that angle there. This is O, and this is E, and this is A, and this is B. We say that angle AOB must always, so this angle AOB is called an angle at center, must be equals to 2 times angle AEB. Right, you can just write here AEB. Right, angle AEB, like this, okay? So this is exactly what we have here. So angle AOB equals 2 times angle AEB. So we use this theorem to explain that the angle at center equals 2 times the angle at circumference. Okay, so yeah, we're excited because now we have exactly that, but this diagram was sort of rotated. Okay, now this part was sort of removed by the examiner. So we have the angle O1, so that in view of this, we're able to see that the angle O1 equals actually 2 times 39 degrees. Right, 2 times 39 degrees. Why is angle O1 equals 2 times 39 degrees? Why? Why 2 times 39? Because of the angle that we just have discussed now, and we say that angle at center. The reason is angle at center. Right, angle at center. Right, angle at center equals 2 times angle at circumference. Angle at center equals 2 times angle at circumference. Okay. So we have been able to find that, so that the angle O1, what is 2 times 39 degrees? It is exactly 78 degrees. Right, so what is the angle O1? So we are able to see that the angle O1 is actually 78 degrees there. Okay, right. And we have been able to answer this question because this question was like, determine the size of the angle O1. And there it is. And we found it. Next question. Right, the next question is determine the size of the angle O2. We want this angle here. What is the size of the angle O2? That angle there with a red question mark. What is the size of that angle there? Right, it is very, very straightforward. And who is willing to find that one? Okay, there are a couple of things that are very important. We are able to see that the angle O2 is actually equal to 78 degrees. The angle O2 is 78 degrees. Why? because the equal chords, right? Equal chords, equal angles. Equal chords, equal angles. These chords are equal here and equal angles there. Okay, because we found first that this angle was 78 degrees. Now, because this chord equals that chord, we're able to realize, therefore, that this angle here is also 78 degrees. Because this angle O1 is subtended by a chord that is the same length as this. So these equal chords subtend equal angles. So in other words, we're able to see, therefore, that the angle O2, which examiner wants, determine the size of the angle O2, the size of the angle O2. O2 is this one. What is the size? It is 78 degrees. Okay, right, we continue. We continue. Next question. Okay, this is recorded and you'll have a chance to watch and chill. The next one, please, I need your maximum participation. In the diagram, S is the center of circle PQRT. Here is S. S is the center. It is the center of circle PQRT. PT is the diameter. PT is the diameter. RST equals x minus 8 degrees. Here is this angle here. RST is x minus 8 degrees. And PQR, angle PQR, P is this one, Q is this one, R is this, is actually of the size 2x minus 40 degrees. Determine the value of x. Find the value of x. Right, anyone, what do we do here and how can we find the value of x? Right, where's an idea on how we can be able to find the size of the angle x? Right, anyone? Anyone home? Okay, first things first, we're able to realize that to find the angle there, we need to use the theorem. There's a theorem here. This theorem says that, okay, there are many theorems we're going to do, guys, so you need to stick around because this is really very important. Here is a circle, and this circle has this center and is sitting like this. We know that if there's an angle here and there's an angle there, the angle at center is actually twice that angle at circumference there. Okay, so the angle at center is 2 times that angle there. Okay, with that said, we continue as follows. So we have this angle. So this angle here, this angle, this whole angle must be equal to 2 times this angle here. Is a diagram like this. Okay, now if this is A, B, C, and this center is O, we say that, and by the angle we're interested in this one, because you can have this one or the one at the bottom. So we then say AOC is equal to 2 times ABC. AOC equals 2 times ABC. Angle at center. Angle at center equals 2 times angle at circumference. Can people hear me now? Yes. Okay, so yeah, this is the theorem. What I'm writing in red is called a theorem. It's sort of the law that we use. But now the question is, we want the whole angle here, but this angle is x minus 8 degrees. And Mr. Examiner, we are good enough and we are smart students because we're able to see that this angle here is an angle on a straight line. And please, the angles on a straight line, we know very well, always add up to 180 degrees. With that, we are done so that we're able to see, therefore, that x minus 8 degrees plus 180 degrees, x minus 8 degrees plus 180 degrees equals 2 times 2x minus 40 degrees. So that in the end, we have what? What then are we able to get out of these here? So it is x plus, what is 180 degrees minus 180 degrees minus 8 degrees? Anyone? 172 degrees. 2 times 2x is what? It's 4x minus 80. Like this. So you have 4x minus x. And here you have 172 degrees. 172 degrees plus 80 degrees. Which is 3x. What is 172 plus 80? It is exactly 252 degrees. 252 degrees equals 3x. We divide the left by 3 and the right. Divide the right and the left by 3, and this implies that x equals, what is 252 divided by 3?
84.
It is 84 degrees. Well done. And the examiner said, determine the value of x. And we can see that the angle x equals 84 degrees. And we've been able to solve this using this theorem. That is, angle at center equals 2 times angle at what? At circumference. Angle at center equals 2 times angle at circumference. Next question. Okay, here's another question. In the diagram, O is the center of the circle. Here is O, and O is the center of the circle. Chord AC is perpendicular to radius OD. Chord AC is perpendicular to radius OD at B. OB, right, OB equals 2x. Okay, let's mark this one, 2x. And AC is 8x, right? From A to C, it is 8x, like this. Show that BD, show that the length of BD is 2x, open bracket, open bracket, the square root of 5 minus 1 units. Show that the length of BD is 2x, open bracket, the square root of 5 minus 1 units. Okay, so we show that the length of BD is that one there. Okay. What are we able to do here at this point? We're able to show that the length of BD is that, so BD is this little bit. It is this little bit here. It is this little bit, right? And that is the length of what? That is the length of BD. And so how are we able to do this? And how do we solve this particular question? First things first, we're able to see that because we have been given that AC is equal to 8x, we're able to see that AB is equal to BC. AB is equal to BC. Why is AB equal to BC? AB equals BC, which is 4x. Okay, so in other words, AB equals BD is equal to half of 8x. What is half of 8x? Is 4x, line from center. Line from center, perpendicular to chord. Line from center. There's this line here, from center. This one, that is perpendicular to the chord. In mathematics, if there's a line from the center that is perpendicular to the chord, we then say it bisects the chord. So this line from center perpendicular to the chord, what does it do? It bisects. It bisects the chord. Okay, that is the theorem. What does it mean to bisect a chord? Well, this line bisects the chord. To bisect is to cut into 2 equal line segments. It divides the line segment into 2 equal parts, or this chord. Okay, now there's some features of these circles, okay, because you're still learning this. A line that cuts like this through a circle from the circumference to circumference is called a what? Is called a chord. Right, so this line is called a chord. And a line that is from the center of a circle to the circumference is called a what? Anyone? It's called a radius. Okay, if I give you a circle like this and I draw a line that cuts like this, what do you call this line here? Quickly, anyone? This line that cuts like this, what do you call it? What do you call it? Please come again.
Is it a bisector? I'm not sure.
Good, it's called a secant. Okay, it's called a secant because it extends both ways and it goes out of the circle. Right. Now there's a line that cuts like this, and if this is the center, goes through the center. What do you call it? Goes through the center. What do you call this kind of a line inside the circle but goes through the center from boundary to boundary? What do you call it?
Diameter.
It's called diameter. Well done. It's called diameter. Okay, so yeah, I'm just teasing you with some of these basics here. Okay, now, if you look at a circle now, okay, at this point, I don't want to start preaching here, but I want to solve this problem. So we are told, therefore, that the whole of AC is 8x. From A to C, this is A, and this is C. And you can see that it's 8x. What is half of 8? 8 divided by 2 is what? Is 4x. And that is why we're able to see that AB equals BC equals 4x. Next. This one, we know it's twice x, this guy. It's twice x. This one is 4x. What is AO? What is it? Now, we want to find the radius. So if somebody tells you that you're given this triangle here, very nice triangle, right angle triangle, we are told that this one is 2x and this one is 4x and this angle is 90 degrees. What do we do here? This one is a right angle triangle and we just want to find the length of the hypotenuse. Anyone?
Pythagoras.
Pythagoras. Well done. Well done. Thank you. Okay. So that OA squared is equal to what? OA squared is equal to 4x squared. So OA squared is 4x squared plus 2x squared. Right, you take the square on the hypotenuse and you find the sum of the squares on this side and that side. And the reason is Pythagoras. Right, it is Pythagoras. Okay, Pythagoras. And therefore, what do we then have? Which means, therefore, at this pointer, you have 4 squared. What is 4 times 4? It's 16x squared. 2 squared is 2 times 2. What is 2 times 2? It is 4x squared. And this is OA squared, like this. And we want to find OA, so we take the square root on this side. But we also take the square root on this side as well. Okay? So we take the square root both sides, and by taking the square root, we're able to get OA. What is 16x squared plus 4x squared? 16 plus 4 is what? It's 20. X squared. And what is this? What is 20? It is 4 times 5 times x squared. Right. And so what do we then have here? This is the square root of 4, square root of 5, square root of x squared. What is the square root of 4?
2.
2. Well done. 2, the square root of 5 and x, like that. Right. So we're excited right now that we got this particular result here. Let us just continue to do a little bit more and to solve this problem in some detail. Okay, now what next do we do here? We just have a little bit to do. Okay, we are done with solving the problem. So we got OA. So we got OA, which is 2 the square root of 5, the square root of x. Okay, so now we have this one here, which is 2 the square root of 5 square root of x. Okay, because radii are equal. A line from the center of a circle to the circumference is called a radius. But also this one is from the center to the circumference. So they are of the same length. They are radii. Right. So in other words, we're able to see that OD is equal to OA, which is equal to 2 to the square root of 5x. It is called what? Radii. Okay, so these are radii. So because they are radii, which is the plural form of radius, there are 2 radii. Right. Because they're radii, now what then are we able to achieve here? We're able to achieve that because now we know the whole thing here. So we're interested in finding BD. We're interested in finding BD. So BD is equal to what? BD is this little bit. So BD is going to be the whole radius minus 2x. What is the whole radius minus 2x? It is 2 to the square root of 5x minus 2x. Like that. And what is this? This means that BD is equal to, what common factor are we able to pick from this? We can pick out the common factor 2x. And therefore, this, if you pick out 2x, it is the square root of 5 minus 1. Square root of 5 minus, which is exactly this. Square root of 5 minus 1 units. Okay, and this here is the answer. So we have been able to prove or to show that the length of BD is 2x, open bracket, the square root of 5 minus. Okay, guys, this lesson is recorded. You can play this again and try to make sense of what we've done, okay? Because some of you might have not learned this, but at 8 p.m., I'm going to be going deeper. At 8 p.m., I'm going to be going deeper. Tomorrow, Sunday, 4 p.m. Every Saturday, 4 p.m. Every Sunday, 4 p.m. During the week, every day at 4 p.m., we have a class. If you're busy at 4 p.m., 8 p.m., you join the class. Every day of the week. Okay, so if you're busy at 4, you join at 8. I need to make sure that everybody is accommodated here. Okay, next question. Okay, in the diagram below, O is the center of the circle. Here is O. It is the center of the circle. PTSR is a cyclic quadrilateral. PTSR is a cyclic quadrilateral. Prove the theorem that states that angle P plus angle S, here is angle P, and here is angle S. Angle P plus angle S equals to 180 degrees. How do we prove this one here? How do we prove this one here? Anyone? Right, we perform a construction. We perform a construction. Right, and in performing the construction is you draw. You draw radii. OR and what? And OT. You draw radii, OR and OT. And this one is 2. And this one is what? Is 1. So that in the end, we use that theorem that the angle O2, the angle O2 is equals to twice angle P. So the angle at center is twice the angle at circumference. Angle at center by angle O2, we mean this one. It is 2 times angle P. Angle at center is twice angle at circumference. And that is the reason. And the reason here is angle at center. Right, angle at center. Let me just space this a little bit. Angle at center equals 2 times angle at circumference. Angle at center is equals to 2 times angle at circumference. And then we have angle O1. Angle O1 is this one here, which is twice angle S. Angle at center. Angle at center Right. Equals 2 times angle at circumference. Angle at center is 2 times angle at circumference. And then we have angle O1 plus angle O2, which is 360 degrees. Why is angle O1 plus angle O2 equal to 360? Why? Why is it that when you add O1 and O2, we do not get anything else? Like we do not get 1000 degrees. Why do we get 360? Why? Why are we saying angle O1 plus O2 is 360 degrees? Why? Anyone quickly? Right.
So I can try.
Yes, what do you think?
So I think a full rotation is 360. So that's why
Yeah.
we're using.
Well done, well done. Yes, angles around a point. Angles around a point. You can say angles around a point, or if you want to say, you say it is a revolution. You can say it's a what? It's a revolution. Okay, angles around a point. So you can study it in 2 ways. This O1 plus O2 is 360 degrees because the angles around a point, or you can say it's a revolution. Okay, right. So at this point, what is angle O1? It is twice angle S. What is angle O2? It is twice angle P, which is what? 360 degrees. Okay, now at this point, what do we do? So we have twice angle S, twice angle P, which is 360 degrees. You divide by 2, you divide by 2, you divide by 2. Which means angle S plus angle P is equal to what? 180 degrees. Okay, so yeah, we can proceed to write this properly because the examiner wrote angle P first. So that angle P plus angle S equals 100 and what? And 80 degrees. Angle P plus angle S equals 100 and what? And 80 degrees. You see that? Yes. Who has a question about the proof? This is the proof. They're going to ask you this question. This question is available at grade 11. It's available in matric. Get ready for war because this is there to challenge you. But now you must be able to prove that if you have a cyclic quad, what is a cyclic quad? A cyclic quadrilateral, right? We write cyclic. Cyclic quadrilateral. Okay, cyclic quadrilateral. A cyclic quadrilateral means a four-sided shape whose vertices lie on the boundary of a circle or on the circumference of a circle. It's called a cyclic quadrilateral, just that way. And this is no exception. The one we were just looking at right now is a cyclic quad. You have a circle like this, and you have this here like this. You have this. And this, yes, please.
If we did the construction
Yes.
from P to S, were you still gonna get the same? Were you still gonna, the proof, was it still gonna be right?
Okay, that's a good question. If we did the construction from P to S, right? Okay. Yeah, okay, if you do the construction from P to S, then the proof, it's gonna give you angle R plus angle T equals 180 degrees. So if you join P and S, it gives you the other angles. Because, yeah, because the examiner wants P and S, it means you must join the other angles. Because it's P and S they want, you must join the other angles. Or the other, yes, the other points. Okay. But yeah, because if you can attempt to join this, but if you join P and S, then you're gonna get R and T in the end. You know, you're gonna get R and T in the end. Okay. Okay, now you need to practice this question, guys. These are past exam questions. You need to practice them day and night. You repeat them. You play the video because I'm gonna send you the video link at the end of our lesson. Next question. In the figure, QS and PR are diameters of the circle with center O. Okay, let's look at that. Here is Q. S And here is P, R, are diameters of the circle with center O, such that PQ is parallel to SR. PQ is parallel to what? To SR. PS is produced to T. PS is produced to T like this. N is a point on the circle. Where is N? N is a point on the circle such that Q1 equals Q2. Okay, this N is a point such that angle Q1 equals the angle Q2. Right? SN is drawn. Right, so you have that SN is drawn. RS intersects QN at M. Right, so you have that indeed. Here is S and here is R. So RS intersects QN at M. Right, the angle S1 is 48 degrees. Angle S1 is 48 degrees, and there she is. There it is. Okay, we are in business now. We sort of understand what is happening. And we have that there are two angles that are equal there, Q1 and Q2. Let me just leave them marked like that in red. Okay, now let us go on, because I'm going to send you homeworks. I'm going to send you homeworks, please. And on WhatsApp, yeah, I'm going to send you homeworks on the group so that you can practice on the group and try some questions on a group where I'll just put the most active ones, like you guys who are active and other students who are active on the group. Determine if this is the size of angle Q1. Want to find the size of the angle Q1. What is the size of the angle Q1? This one here. Right. I know that it is very, very straightforward, and somebody can be able to find that with ease. With ease. Right. So first things first, we are able to see something very, very important here. That we know that angle Q1 equals angle Q2. Why? Because it was given there. Right, but we most certainly know that this angle here must be the whole angle here. Because there's a theorem that says this. There's a theorem that says this. An angle that is here is equals the angle there. An angle that is here is equals the angle there. Why is this? Exterior angle of cyclic quad. Exterior angle of cyclic quad equals interior opposite angle. It's a theorem, this. It is a theorem or a law. And that is what the examiner wants us to use, because we are seeing a cyclic quad here that is like this. This cyclic quad is just this way, and it goes around here. It goes around like this. So they've given us this angle here, an angle that like sits here, and it's because the angle that is inside the the circle there. So first things first, we write the geometry. That is what you are doing this term, most of you guys. So we say that angle S1 is equal to angle Q, which is equal to 48 degrees. So angle S1 is angle Q, which is 48 degrees. Why? Because of the exterior angle of cyclic quad. Right, exterior angle of cyclic quad. So the fact that therefore this angle S1 is equal to what? Is equal to the whole of the angle Q here. And the angle Q is equal to S1, and S1 is 48 degrees. Right. So S1 is Q, but S1 is 48 degrees because it was given that way. Why is S1 equals Q? Because of the exterior angle of cyclic quad. Next, we also have that. So in other words, obviously the implication is therefore that This is angle Q equals 48 degrees. Angle Q1 plus angle Q2 is equal to 48 degrees. The angle Q is Q1 and Q2 together, combined. But now, so we can put a but here. Angle Q1 is equal to angle Q2. Why is angle Q1 equals angle Q2? Angle Q1 is equal to angle Q2 because it was given. It was given. It was what? It was given. And with that mentioned, it means therefore, here we shall then have that we want only Q1. So wherever there is Q2, we shall put Q1. So that we have Q1 plus Q1 equals 48 degrees. So wherever there's Q2, we shall put Q1. So that 2Q1 equals 48 degrees. And now we continue to analyze this. We divide both left and right by 2 so that the angle Q1 is equal to 24 degrees. We found that the angle Q1 equals 24 degrees. Where's the question? Who has a question? Right, so we found angle Q1, which is 24 degrees. We found angle Q1, which is 24 degrees. Right, so what do we have now? What do we have now? We continue. We continue. Okay, next question. Next question. Okay, the next question is we want to find, so we found that this one is 24 degrees and this one is 24 degrees. Okay, now we want the size of angle R, this one here. We want the size of the angle R. Very easy. Anyone? Anyone? Angle R is equal to what? Okay, there's what you call the bow tie theorem.
24.
24 degrees. Well done. That's Tenulo, right? Okay. Yeah. Thanks, Tenulo. Right. So if there's an angle that sits here is equal to the angle that sits there, and an angle that sits here is equal to the angle that sits there. And we say, therefore, the angles are often marked like this. And we say that these are angles in same segment. Angles in same what? Angles in same segment. Because of that, we're able to see that there's this one here that is from the boundary of the circle. And there is this one here that is from the boundary of the circle. So we have this one here is equal to this one there. So which means, therefore, angle R is equal to angle Q1. Right, this angle here is equal to this angle there, which is equal to 24 degrees. Why is angle R equal to the angle Q1? Because these are angles in same segment. Angles in same segment. Angles in same segment. So angle R is equal to angle Q1, which is 24 degrees. So angle R equals angle Q1, which is 24 degrees, angles in same segment. Angles in same segment. Okay, we're done. Next question. Let's see what else is next. We want right now the size of the angle M1, this one. This one here. Who can find angle M1? Anyone? This one is grade 8. Even grade 7. Who can find the size of the angle M1? Quickly. Are people sleeping? Anybody home? Okay.
Unit alternate angles.
Please come again.
Alternate angles.
Yes, you're on point. You're on point. So this line here is parallel to this one. This line is parallel to this. And this is forming F. What do you call the angles in F? If this one is parallel to this one, then this angle is equal to this. Why? What do you call those angles? What do you call those angles?
Corresponding.
Yes, they're corresponding. Well done. So in other words, but we already know that this angle Q is equal to what? It's equal to 48 degrees. So which then means that angle M1, which what is the examiner wants? These angles are called corresponding. Right, they're called corresponding angles. Right, so that angle M1 is equal to angle Q, which is equal to 48 degrees. Right, what are these called? They're called corresponding angles. They're called corresponding angles. Okay, now each time you mention corresponding angles, please, students, always remember, learners need to always remember this. Tell the examiner which lines are parallel. Each time you mention corresponding coincident angles, mention which lines are parallel. What lines are parallel here? The line PQ is parallel to the line SR. The line PQ. The line PQ is parallel to the line what? SR. The line PQ is parallel. If you have parallel lines, then you have corresponding angles. Tell the examiner that way, but all the time. Okay, there are many things you can do. There are many ways to get the answer here at this point. There are very, very many ways to get the answer at this point. But yeah, we're excited and we are very, very delighted to do this question. Right, we found angle M1. Next question, please. Right. Right, at this point, prove that ST is a tangent. This is S, and that is T. Prove that ST is a tangent to the circle passing through M, N, and S. The circle passing through M, N, and S. There's a circle that is passing through M, N, and S. So there's a circle that is like this. Circle like this. Another circle, different from the one the examiner drew. Okay, but we want to prove that ST is a tangent to the circle that passes through. So to prove that ST is a tangent to the circle that passes through, we must just prove one thing and one thing only. Right, you must just prove the 10-chord theorem. Demonstrate that the 10-chord theorem is holding true. So that this one is equal to that one. So that the angle S1 here is equal to the angle M1. We know that this angle M1 is already 48 degrees. And this one is 48 degrees. That we know already because we know that this one here, this angle Q is 48 degrees. Okay, we have already dealt with that one. So now, okay, if there's an angle here, it is always equal to angle there. This is called the 10-chord theorem. Please. It's a theorem, guys. You have not seen it in class. There are many theorems I'm still going to do. Many I'm going to prove. So please stay tuned. Okay, but we're able to see that we know that this one is 48 degrees. The examiner gave 48 degrees, but this one is also 48 degrees. So that we're able to see, therefore, that angle S1 is equal to the angle M1. And these guys are equal to each other, and they're equal to 48 degrees. Why? Okay, they're equal to 48 degrees because it was proved. Proved above. It was proved above. So the conclusion is that therefore ST, this one, ST is a tangent. Is a tangent to circle M and S. To circle M and S. So we've shown that ST is a tangent to circle M and S. ST is a tangent to circle M and S. Why? Because it's a tangent if you can be able to demonstrate that this is like the turn chord and it plays the turn chord game. And if it plays the turn chord game, we're excited to have this particular result here. So this here is equal to this here, and this here is equal to this there. Okay. And this most certainly is good news. So ST is the tangent to the circle M N S. Right. So we proceed to solve these particular questions. It was 2 marks there. Let's look at the next question. Let us look at the next question. Right. We are proceeding. Right. O is the center of the larger circle. O is the center of the larger circle. Okay, here is O. It is the center of the larger circle. RTAP. Right. Circle RTAP. Right. So if you look at this is P, this is R. So this is R. Okay. And this here is T, and this one is A, and this is P. So R, T, A, P. OP is the diameter. Right. So in other words, if you look very carefully, there is O, and here's O, and here is P. So you can see that OP is what? Is a diameter. What is next? What is next? Right. Is the diameter of the smaller circle PSO. PSO. NP is the tangent to both circles at P. So NP is a tangent, this one is a tangent to both circles at P. Rn is perpendicular to NP. Rn is perpendicular to NP. Here is NP, and Rn is perpendicular. Rn is perpendicular to NP. Here is Rn. It is perpendicular to NP because it makes an angle of 90 degrees here. Okay, let P1 be X. Right, so here's P1. They made it X for us. The examiner has already made it X. P1 is down here, but the examiner has already made it what? X. Prove that PR bisects ORN. Here is O. Here is R. And here is N. We need to prove that PR. Here is PR. We're not supposed to prove that it bisects ORN. O here. R is this one. And N is that. Okay, now let us look at this very, very carefully and try to analyze this question with ease. So what to prove that PR bisects the angle ORN, we must prove that this angle here is equal to that angle there. R1 equals R2. That's what you need to prove here. R1 is equal to R2. Let us prove this here. How do you prove that R1 is equal to R2? Because you've already been given a tangent. NP is a tangent. We can try to, this is about investigations, because if you do the turn chord theorem like this angle here is equal to this angle there is the theorem. And this theorem is called the turn chord theorem. Turn chord theorem. so that in the end, we are good. So we start by saying angle T1. Angle T1 is equals to what? Angle T1 is equals to X. So angle T1 is X. Angle T1 is X, which is the Chord theorem. So we're sure that this angle here is equal to this angle there, because we have this kind of a triangle. Okay, Chord theorem. And then we are most certainly in business. We are most certainly in business. What else are we able to achieve at this point here? For example, what else are we able to achieve in relation to the angle O1? Okay, there's a theorem that says that if you have a circle like this, and you have this here, so the angle here and the angle there, the angle at center is actually 2 times that one. It is bigger than that one by a factor of 2. So with that mentioned, we're able to see that sometimes even if you can slice it like this, you can slice it like this, but this angle here is equal to 2 times that one. So which means that angle O1 is equals to 2 times this angle X. Right, with that said, it means angle at center, angle at center, angle at center. Right, angle at center equals 2 times angle at circumference. Next. So which means that this angle is 2x. You can just put 2x there. What is the angle P2 now? What is the angle P2? You look at this and think, but think very, very carefully. Right, so there are a couple of things that you need to, this one is a tangent and this one is a radius, so this angle there. So in mathematics, if you have a tangent and a radius, then they're perpendicular to each other always. They form an angle of 90 degrees. This one is a radius and this one is a tangent. In mathematics, the angle between them is 90 degrees. Which means that angle P2 this one, is 90 degrees minus X. This whole angle is 90, but this little bit is X here. So now if you then say P2, it will be 90 minus the X. Why? Tangent, perpendicular to diameter. The tangent perpendicular to what? To diameter. What is the angle R2? What is the angle R2 at this point? Right, so let us think of this. What is the angle R2 if this one is 90 degrees minus X, this one? And now you have an isosceles triangle. In this triangle that has 2 sides equal, it's called isosceles triangle. So in an isosceles triangle, you always have that the base angles are equal. So a radius from the center to the circumference is a radius. From the center to the circumference is another what? It's another radius. So we have an isosceles triangle so that this P2 must be equal to the angle R2. So which means that angle R2 Angle R2 equals P2 equals 90 degrees minus X. And these are angles opposite equal sides. Okay, because if you have an isosceles triangle, this angle equals this. So at this point, this angle equals this. So which means that angle R2 is equal to the angle P2, and the P2 is the 90 degrees. Angles opposite equal sides. Or you can say base angles of an isosceles triangle. Okay. Okay. Now, what else can we say here? The angle R1. The angle R1 is 90 degrees minus X. The angle R1 is 90 degrees minus X. Why? Because of angles in triangle. Angles in triangle. If you add this plus this plus this, you must get 180. So this one must be, you must just say 90 degrees minus X to get this one. Or so that when you add this plus this plus this, you get 180 degrees. And what is then the conclusion about everything here? The conclusion about everything is that the angle R2 is equal to the angle R1, which is equal to 90 degrees minus X. The angle R2 is equal to the angle R1, which is 90 degrees minus X. And then what is the conclusion? The conclusion in the end is that PR bisects ORN. The conclusion, therefore, that P is this one at the bottom here. P is this one at the bottom. So PR bisects angle ORN. How does it, to bisect in mathematics is to divide. The word bisect means to divide into two equal parts. So ORN is this angle. So if this PR bisects, it means that this PR divides this angle here into two equal parts, which means that R1 equals R2. R1 equals R2, like that. So yeah, take note of that. And we are moving to the next question. In this particular question now, we need to prove that angle ROS is equal to angle PAT. Angle ROS equals angle PAT. So in other words, we need to prove that angle ROS is PAT. PAT. ROS, this one here. Angle ROS is angle PAT. Angle ROS is angle PAT. Angle ROS is angle what? Is angle PAT. So yeah, just take note of that. Right, let's look at this one and let's prove that one together. Very, very easy result there to prove. Very, very easy result to prove. Right, let's look first at angle PAT. PAT is equal to what? Right, so the couple of things that are very, very important. This angle is 90 degrees minus x. And this one is also 90 degrees minus x. But this angle plus this angle must give us 180 degrees. So what can this one be? It must be 90 degrees plus x. So that 90 plus 90, what is 90 plus 90? It's 180. Then these x's will cancel each other. X minus x is 0. So we start by saying angle PAT. Angle PAT is equal to 90 degrees plus x. Why? Opposite angles of cyclic quad. Opposite angles of cyclic quad. Opposite angles of cyclic quad. Right, of cyclic quad. Because a cyclic quad is a four-sided shape, and we've already proven that if you have the opposite angles of a cyclic quad, then if you add them up, you get 180 degrees. Okay, that we have been able to show. Okay, next. What else do we have? Right, there are a couple of things that we need to consider here. And it is the fact that the angle S2, this one here, is equal to 90 degrees. It's equal to 90 degrees. If the angle S2 is 90 degrees, let us reason that together. The angle S2 is 90 degrees. Why is the angle S2 90 degrees? Because there's a line from center. Here, there's a line from center that is perpendicular to this chord. That is perpendicular to this chord. Right. So the reason for that is a line from center. A line from center. Perpendicular to chord. Line from center, perpendicular to chord. Okay, I want you to think of that very, very carefully. And make sure that you most certainly can be able to make proper sense of that. All right. So the angle S2 equals 90 degrees because line from center perpendicular to chord. There's a line from the center that is certainly perpendicular to the chord there. Okay, yeah, so just take note of these. Take note of that. Because I want to mention that OP is the diameter of the smaller circle. OP, this one, is the diameter of the smaller circle. In mathematics, we always say that a line, a diameter, subtends an angle of what? Of 90 degrees. Okay, learn this because most of you guys are still learning geometry. So if you have A line through the center of a circle is called a diameter. It subtends an angle of 90 degrees here. It subtends an angle of 90 degrees there. Like this. Okay. So that now this diameter here, this diameter of the smaller circle is going to subtend an angle of 90 degrees there. But it's a straight line, so that S2 is also 90 degrees. And that is the point we're trying to raise. Okay. Now, there are a couple of things that, and also, yeah, you can say many things. For example, about the fact that S2 equals 90 degrees. S2 equals 90 degrees because we said line from center that is perpendicular to a chord. Okay, so it is most certainly one valid reason. And you can also say that because you have already seen that this one is the diameter, so the angle S1 is equal to the angle S2 equals 90 degrees. Why is the S1 90 degrees? Because it is an angle in semicircle of the smaller circle. Right, so you can say that the angle S1, the reason for this is that angle S1 is equal to angle S2, and angle S1 equals S2 equals 90 degrees. Why is S1 equals 90 degrees? Angle in semicircle. In semicircle. Okay, in mathematics, when we have a diameter that subtends an angle at circumference, it's a theorem, it's a law. We're not reinventing the wheel. Okay, for those who are learning geometry, there's still a lot of geometry, please, we're gonna do. So we say the reason for this, we say it's an angle in semi what? Semicircle. Angle in semicircle. Now we have, let's see now. ROS. ROS is equal to how many degrees? Right, so the angle ROS now is exactly this one. And I want you to look at these and look at it very, very carefully. Right, so what is the size of the angle ROS? Right, there are a couple of things that you have already seen. And I want us to tell what this is, the angle ROS. Right, so the angle ROS at this point is exactly 90 degrees plus X. The angle ROS is actually, because you know that this one is X. And this is the angle ROS. From grade 10, an angle like this is equal to the sum of these two angles. So normally in grade 10, you say this one is A, B, and this one is C. And this one is 1. So you say that angle C1 is angle A plus angle B. Remember this. Angle C1 is A plus B. Exterior angle of triangle equals the sum of interior opposite angles. So that angle ROS, which is this one here, is equal to the sum of the angles inside this one and this one, which is 90 degrees plus X. Next is a grade 10 theorem, that one. Let us think now together. So if this angle ROX is actually, this one is 90 degrees plus X, the ROS, angle PAT, this one is also 90 degrees plus X. This one is also 90 degrees plus X. What is happening here? What is happening? That's ROS is equal to PAT. Yeah. Thus ROS is equal to PAT. Because we can see that ROS is 90 plus X, but angle PAT is also what? It's also 90 plus X. So this ROS is equal to PAT because they are both 90 plus X. And the reason for that would be can be viewed as follows. You can think of these to actually mean that these are both equal to 90 degrees plus X. They're both equal to 90 degrees plus X. Okay. We continue. Okay, this lesson is being recorded, guys. So yeah, very, very relaxed. You're not gonna lose anything here. Every single bit of thing is above board and things are recorded for your convenience. So yeah, stay relaxed. Stay very, very relaxed. There are certain things I want us to do. Right, there are certain things I want us to discuss. Okay, there are certain things I want us to discuss here. Okay, I want us to look at this question very briefly. In the diagram, you have the angle A with the vertices, which is a vertex, a point, with the coordinates -2 and 2, B 6 and 5, C 0 and -3, D X and Y are vertices of a quadrilateral having AD parallel to BC. So BA produced has X intercepted E. Okay. So in other words, BA produced, right? So in other words, you have BA produced, there's an X-intercepted E there. BD and AC intersected M. So you have that BD, here is BD, and here is AC, they intersected M. And with coordinates T and 0 is the point on AD. N with coordinates T and 0 is a point on what? On AD. Determine the gradient of BC. Let's find this one. Okay. Determine the gradient of BC. Okay, so now, if we have B and C, how do you find the gradient of BC? BC is like x1, y1, and you have x2, y2. So if you want to find the gradient of BC, it is change in y, change in x, which is y2 minus y1 over x2 minus x1. What is y2? Y2 is -3 minus y1. What is y1? It is 5 divided by, what is x2? It is 0 minus x1. It is 6. What is -3 minus 5? -8 over -6. What is -8 over -6? 4/3. 4/3. Right, so in that, the conclusion here is that hence, right, the conclusion is hence, the gradient of BC is equal to 4/3. Okay, so let us continue right now. And we're just discussing a little bit of this section is called analytical geometry. We are discussing a section that we call analytical geometry. Okay, we're coming back with more circle geometry at 8 p.m. Please, I'm going to send the link. Yeah, I'm also going to form the WhatsApp group so that we can discuss the things together there. Determine the equation of AD. AD. Determine the equation of AD. Right. Anyone? What is the first step? How do we find the equation? What is the formula? What is the formula? First and foremost, we know that the gradient of AD is equal to the gradient of BC. And the gradient of BC equals what? 4/3, because AD is parallel to BC. Why? It has been given. Okay, so this is what we have. So this one is parallel to this one. Parallel lines have equal gradients. Okay, so we learn this. We say parallel lines have equal gradients. Right. So we continue. Right. Once again at 8 p.m., we're going to be right back here on this platform. I'm going to send the link and we're going to continue doing more. So yeah. Now we want to find the equation of AD. How to find the equation of AD? We use the formula y minus y1, which is m into x minus x1. This line AD passes through a point. So AD passes through the point this. So the point is this with x1, y1, which is y minus 2, which is 4/3 into x minus x1 is minus 2, which is the y minus 2. It is 4/3x plus 8/3. 4/3x plus 8/3 plus 2, which is 4/3 x plus, and this is exactly, what is 8/3 plus 2? You know that one? 14/3. 14/3, like this. Exactly 14/3. Okay? So yeah, we just wanted to find the equation of AD. Equation of AD there. Next question. Now I want to find the value of t. T is this one. How do we find the value of t? First and foremost, we're able to see that t is an x-intercept. Is an x-intercept. So is the x-intercept of t, because now t is like the x-intercept, and this is x and this is y. X-intercept of line 80. Okay. Y equals 4/3x. Y equals 4/3x plus 14/3. Okay, now to find the x-intercept, you let y be equal to 0. If y is 0, 0 equals 4/3x plus 14/3. Like this. Because to get the x-intercept, what you do, you let y be 0 to get the x-intercept. Because you already know the equation of this line. The equation of this line is 4/3x plus 14 over 3. Like this. Which means minus 14 over 3 equals 4 over 3x. You multiply it through, which means you have minus 14 equals 4x. And this means that x is minus x is minus 14 over 4. Minus 14 over 4 is minus 7 over 2. So, which means this one here. And obviously, and the implication therefore is that t is equal to minus 7 over 2 because this is x and x is t here. T, because they said find the value of t. So t is exactly minus 7 over 2. Right, so we take note of that. I think I must thank you guys for joining us, and it was exciting discussing geometry with you. We first looked at Euclidean geometry. So the first discussion was on Euclidean geometry. Okay. And this kind of geometry we're looking at right now is called analytical. It's called analytical geometry. And if you don't want to call it analytical geometry, what is it called? It's also called coordinate. Coordinate geometry. So we looked at two geometries, Euclidean geometry and analytical geometry, also called coordinate geometry, this afternoon. And so, but yeah, at 8 p.m., I'm going to be right back. If you are busy at 8 p.m., we're going to be there online for 1 hour at 8 p.m. So we're going to be there not for very long, from 8 up to 9. At 9, you go to sleep, you go to do your things. 4 p.m., tomorrow, Sunday, we're on. If you're busy at 4, you join us at 8 p.m. 8 p.m., we're going to do 8 p.m. to 9 p.m. so that we don't keep you for very long. You also have sleeping time. All right. Otherwise, yeah, it was exciting having you guys. We're going to meet again at 8 p.m. More cyclic geometry at 8 p.m. and more fun. Okay. So thanks, guys, for joining us. I'm going to send the link to this lesson very soon. Yeah. Thank you and enjoy your evening and see you at 8 p.m. I'm going to send the link. Any question? Who has a question? No question. Right. Thank you. Thank you, everyone. And goodbye to you. Goodbye.
Bye-bye, sir.
Goodbye, Tenulo and everybody.
Bye, sir.
Bye. Pegelelo. See you at 8. See you at 8 p.m. See you at 8 p.m. Bye-bye. Goodbye. Goodbye.